Welcome back, my dear students. Now let us see the multiplexing schemes. So it is one of the important operations performed by the digital communication systems. Multiplexing techniques are used to combine several message signals into a single composite message so that they can be transmitted over a common channel. So in multiplexing technique, more number of signals from different sources are going to be combined and the composite signal is transmitted over the channel. So which can share the different resources of the channel like bandwidth, power, time and so on. The multiplexing techniques ensures that the different message signals in the composite signal do not interfere with each other and that they can be conveniently separated out at the receiver end. So they should be conveniently separated at the receiver end because we are going to multiplex different message signals in the composite signal. So they do not interfere with each other and they can be conveniently separated at the receiver end. So the multiplexing technique should ensure this one. And there are two types of multiplexing. One is frequency division multiplexing and second one is the time division multiplexing. So the frequency division multiplexing is used with signals that employ analog modulation, whereas the time division multiplexing is used with digital modulation techniques, where the signals to be transmitted are in the form of one bit stream, a bit stream. Let us see the frequency division multiplexing. So in frequency division multiplexing, different message signals are separated from each other in frequency domain. So this is the frequency division multiplexing circuit. Here the three message signals modulates a different carrier. So three signals are there, M1 of t, M2 of t, M3 of t, and all the three signals are modulates a different carrier, omega C1, omega C2 and omega C3. And here the most commonly used modulation technique is SSB, single sideband modulation technique. So we can use any type of modulation as long as we ensure that the carrier spacing is sufficient to avoid the spectral overlap. So the spectral overlap should be avoided such that we can choose any of the modulation schemes. But in general, single sideband modulation scheme is used because it is a analog technique. So it is used with the signals that employ analog modulation techniques. So on the receiver side, band pass filters are used. So these band pass filters separate out the signals which are then coherently demodulated as shown. See, so here the carrier signal omega C1, omega C2 and omega C3 are used at the receiving side also. Okay, so that means they are coherently demodulated. Coherently demodulated means the carrier signal which is used at the receiving side should be in synchronism with phase and frequency with respect to the one which was transmitted at the transmitting side. So here we have used a carrier omega C1, omega C2 and omega C3. And here it is coherently demodulated. That means the locally generated carrier should be in synchronism with the one which is transmitted at the transmitting side. And the composite signal formed by combining different message signal after they have modulated their respective carrier signals. So that may be used to modulate another high frequency carrier before it is transmitted over the common link. So this composite signal is used to modulate another high frequency carrier before it is transmitted over the common link. So in that case, these individual carrier signals are known as sub-carrier signals. These individual carrier signals are known as sub-carrier signals. So this FDM is used in telephony, commercial radio broadcasting, both AM and FM, or television broadcasting, communication networks, and telemetry. So FDM is used in telephony, commercial radio broadcast, television broadcast, communication networks, and telemetry. So we can use it. So in the case of commercial AM broadcast, the carrier frequencies for different signals are spaced 10 kilohertz apart to minimize the interference. But for high fidelity voice signals, this separation is not adequate, since the spectral coverage of the high fidelity voice signal is of 50 Hz to 15 kHz. For this reason, AM broadcaster stations using adjacent carrier frequencies are usually far apart to minimize the interference. So in the case of FM broadcast, the carrier frequencies are 200 kHz apart. Whereas in the case of long distance telephony, the carrier frequencies are 4 kHz. Therefore, in this way, this is the concept, basic concept of frequency division multiplexing. So which is used to employ analog modulation techniques, and SSB is the most commonly used modulation technique here. And the message signals are different message signals modulates different carrier, and it can be used in broadcasting, communication networks, telemetry, and so on. Now coming to the time division multiplexing. So time division multiplexing is used for simultaneous transmission of more than one pulsar signals over a common communication channel. So basically in pulse amplitude systems, the duration of the pulse is much less than the time period of pulses. See, this is the pulse amplitude modulated waveform, and the duration of the pulse tau is much less than the time period of pulses. So this is the time period of the pulse, where the pulse duration is tau, which is much less than the time period of these pulses. That means this tau is far less than Ts. Thus, no information is being transmitted through the system for most of the time. Therefore, the time space Ts minus tau can be utilized to transmit information from other signals. So this gap is used to transmit the information from other signals, and this can be achieved by a process known as time division multiplexing. This can be achieved by a process known as time division multiplexing. See, so these are the different signals. So this is the composite signal of time division multiplexer signal. So the signal numbers M2, M3 and M4 are transmitting information with the help of samples numbered M2, M3 and M4 respectively. So this is along with the samples numbered 1 of the signal number 1. So along with this sample 1, these signals are also being transmitted. Here the time period Ts is equally divided between the 4 signals, thus allocating a time slot of Ts by 4 to each signal. So this period is subdivided into 4 different time slots. Each time slot is of duration Ts by 4. So the duration of time slot is such that Ts by 4 should be greater than tau, such that we need to select the duration. And there is a guard time Ts by 4 minus tau between all successive sampling pulses. So in order to ensure that there is less crosstalk between the signals, so a guard time should also be provided in order to reduce the crosstalk. And this figure shows the basic concept of time division multiplexing. So here the multiple pulsed signals are fed to a type of electronic switching circuitry, so which is defined as commutator. So all the message signals which have been sampled at least at Nyquist rate are fed to the commutator. So these are the different signals, and these signals has to be at least sampled at the Nyquist rate. So they are fed to the commutator. The commutator interleaves different samples from different sample message signals so as to form a composite interleaved signal. Therefore, this composite signal is now transmitted over the link. So it is not compulsory that all the signals are having the same bandwidth here. So suppose in case all the message signals have the same bandwidth, one commutation cycle will contain one sample from each of the messages. But in case signals have different bandwidths, then one would need to transmit more number of samples per second of the signals having larger bandwidths. If the bandwidth is same, then the commutation cycle will contain one sample from each of the messages. So if the bandwidth is different, then different number of samples will be transmitted based on the bandwidth size. For example, if there are 3 message signals, so whose sampling rates are 4.8 kilohertz, 4.8 kilohertz and 9.6 kilohertz, for example. That means that the first 2 signals have the same frequency, but the third signal is having twice the frequency of the previous 2 signals. Then each cycle of commutation will have one sample each from the first 2 messages. So whose frequencies are 4.8 kilohertz, and 2 samples from the third message, since its frequency is 9.6. And at the receiving side, the composite signal is demultiplexed using similar type of electronic switching circuitry, and that is synchronized with the one used at the transmitter. Okay, so similar type of circuitry is used at the receiving side, and that is synchronized with the one which is used at the transmitting side. And the TDM is widely used in telephony, telemetry, radio broadcast and data processing. And here these are the 2 important formulas, so which are very important to solve the problems. If capital T is the sampling time interval of the time multiplexed signal of n different signals, each having a sampling interval of Ts, then capital T is equals to Ts by n. So capital T is the sampling time interval of the time multiplexed signal, and Ts is the sampling interval of each of the signal, and n is the number of different signals that are going to be multiplexed. So the relation is T is equals to Ts by n. Also, if time multiplexed signal is considered as a low pass signal having a bandwidth of FTDM, and Fm is the bandwidth of individual signals, then FTDM is equals to n into Fm. That is, the bandwidth of the multiplexed signal is equals to n times the bandwidth of the individual signals.